So it's basically what we have as our base, all right? We do need the perimeter to find the area of that base. Okay, so what is my formula for the area of this base? 1/2 apothem times perimeter. All right, so perimeter's easy, right? It's just 6 times 6, right? Easy enough. So we have that piece. We need this piece right here. All right, and so we do need to do our right triangle there. All right, if it's a hexagon, what's that triangle going to look like? We take 360 divided by 6, right? And then we divide that in half actually to find this. So this is 30 degrees right there. I have the short side of a 30, 60, 90 triangle. The apothem is the long side. So what is my apothem?
3 squared root of 3.
Yeah, so it's 3 squared root of 3 because this whole side length is 6. That means this piece is going to be 3. This is going to be 3 squared root of 3. So my apothem is 3 squared root of 3. All right, that's the area of my base. All right, and then I just multiply that by the height. The next one is a cone. They have given us that it is a 60-degree angle. I am assuming the 20 is the slant and not the perpendicular height based on the picture.
This book cannot draw.
It's a 30, 60, 90 triangle. All right.
Why does your picture look so different?
Yeah, mine's like...
All right, so they told me this is 60. I'm assuming that's 20.
No, it's the...
So based on the drawing that they have, you would have pi times r squared, right? Times your height, which is 10. And all of this is times 1/3. Based on what they gave us, I disagree with this answer. And even if that was the height, I think we'd get a bigger answer because you'd have an even taller cone. So based on that, if you have a 30, 60, 90, then you should have a radius of 10 squared root of 3 and a height of 10. And so you'd say 1/3 pi r squared times your height, which is that answer, which is like 3,000. You have a triangular pyramid here. So based on this is an isosceles triangle, right? 11, 11, and 11. So you could, if you pull that one out, so pull it out, isosceles triangle. You have 11 here, you have 11 here. This is 6. You can actually do this if you want to. This would make that 3, and you can use Pythagorean theorem. So your height is going to be the square root of 11 squared minus 3 squared. Okay, you can pull that out. All right, so a height of approximately 10.6. All right, so on this one, your base is 1/2 base times height, right, for your triangle. So 1/2 your 6 times your 10.6, okay? And then you have to multiply that by the height of the actual pyramid, which is 4, right? And then you also have to multiply that whole thing by 1/3. So what you're trying to do here is figure out what your base is. You do have to remember things like isosceles triangles, right? That's an isosceles triangle. You do have to remember that you can do a perpendicular down that will cut it in half. And then, of course, Pythagorean theorem, I don't think you'll ever forget. So you do have to solve a little bit within it, but then you just area of the base times the height divided by 3. They actually show you how they come up with it. They actually take these wedges that create pyramids, and they use actually a theorem of like a summation type theorem. But what it works out to is 4/3 pi r cubed. For some reason, this is an easy one to remember. I don't know. 4/3 pi r cubed is the volume of a sphere. So surface area of a sphere is 4 pi r squared. Volume of a sphere, 4/3 pi r cubed. So really the only thing you need to know for a sphere is the radius for both surface area and for volume. You really only need to know the radius. It's really easy to solve into it. If you look at the volumes over here on example 1, find the volume of the sphere. They gave us the radius. So you literally just plug it in. 4/3. Nope, if I can write without that. So 4/3 pi 24 cubed. It's going to be a big volume here, but round to the nearest, I think 10th is what they do. It is cubed. The next one, they gave us the circumference, and we need the radius. How do we find the radius if they gave us the circumference?
Divide by pi, then divide by
Right, so radius in the circumference formula is going to be 2 pi r, right? Equals your circumference. So if you just plug that in, then to find your radius, you just say 36 over 2 pi, right? Or 18 over pi. And then you can just plug the 18 over pi into your formula, 4/3
So many formulas.
pi r cubed. Right. So when you plug that in, there we go. Easy enough. Name of a hemisphere to find it. Right, so you just take your 4/3 pi r cubed and you divide it by 2. It's a half a sphere. So for this one, you would say 4/3, what's my radius? 2 cubed, and divide that by 2, or multiply by 1/2.
Wow.
16.8 cubic feet. Find the volume of a sphere or hemisphere. For the first one, they told us the radius is 13 inches. So you should have gotten 9,202.8 cubic inches. Diameter of 12.5, divide that in half to get your radius, then plug it in, getting 1,022.7 cubic centimeters. For this number 5, they gave us the radius of 4, so 268.1. Number 6, they gave us the circumference, so you had to solve for your radius. You should have gotten 98.5. And 7 was a hemisphere with a diameter of 8.4. You should have gotten 155.2. All right, the last one said compare the volumes of a sphere with a radius of 5 inches and a cone with a height of 20 inches and a base with a diameter of 10 inches. They were the same. And they left it in pi, but if you did it as a decimal, that's fine as well.